Pencils down and colored pens up. If you're reaching into your bag now to get it, that tells me that you're not yet used to the procedure. That you need your colored pen every day in class, and you're going to need your calculator every day. So pencils, colored pens, calculators. Have them out. Mark your answers correct or incorrect. Anything you get wrong, write down the correct answer and see if you can figure out where you went wrong. These are a little bit difficult for me to call on volunteers, so I'm going to reveal the answers and then we will discuss. So, number 1. I was looking for 4 times the quantity, n plus 3, is greater than 12. It doesn't matter what letter you chose. Number 2. 6 less than the sum of the square of a number and 18 equals 20. That's what I was looking for. It doesn't mean it's the only possibility. Okay, but I thought I gave them back to you. I think so. Yeah, because I'm not using them. Sorry. Sorry. I apologize for the interruption. Okay. So, again, this is not the only possibility, but this is primarily what I was looking for. So, comments, questions, maybe you have an answer that looks different, but you think it's right. Any concerns? Brandon and then Aliana. Go ahead, Brandon.
What if you didn't have the parentheses?
For which one?
The second
Well, it's actually still going to get the same answer. So, if you do not have the parentheses for number 2, I will accept it. Okay? Because you will end up with the same answer either way.
Does it matter if you put it in a different order?
Which question and what?
For number 1, I put 3 plus n instead of n plus 3.
That's the same thing.
And for number 2, I put n squared plus 18 after.
Okay, well in that case, it does make a difference. Okay? So you have 6 minus the n squared plus 18. Unfortunately, that is incorrect. And we spoke a little bit about that phrase less than. The phrase less than is the one phrase that really you have to be very careful about. The only way to represent 6 less than something is you're subtracting 6 from it. Okay? So you cannot switch these around. The only ones that you don't ever have to ask me about is anything with addition. You can always switch them around. But the subtraction cannot be. Do you understand why? Kind of. Okay. That's a good answer. Let me get to her and then I'm going to come back. Go ahead. Unfortunately, no parentheses on the first one will get you a different answer, and that would be incorrect. But let me just clarify. You have 4n plus 3. Is that what you have? Yeah, unfortunately, that's going to get you a different answer, and that is not correct. And in this case, it does say the quantity. So 4 times the quantity, you have to put the parentheses. Okay? Good. So let's come back to less than. I'm going to use a different example. I have $3 less than Aliana. Okay? I have $3 less than Aliana. Make up an amount of money in your pocket. 6? Okay, so I have 3 less than you. So the question is it 3 minus 6 or is it 6 minus 3? You said you have $6 in your pocket and I have 3 less than you. how would we find out how much I have? Would we do 3 minus 6 or 6 minus 3?
6 minus 3.
You sure? Yeah, we would. We would do 6 minus 3. First of all, you can't have negative money. So 3 minus 6 would be negative 3, and that doesn't make any sense. And again, I'm just trying to illustrate that it's a little counterintuitive. It means it's not what you think it would be. And so it's not just whatever comes first. It's not 6 minus whatever comes after that. Less than works differently. Okay? With a little time and experience, it will start to work itself out in your head. Okay? Okay. Are there any other questions on either of these? Okay, please put the warm-up to the side. Today we're going to talk about equations and inequalities, specifically what they look like and how to tell whether or not a value is a solution. That's the major goal of today, is to be able to tell whether or not a value that you found is a solution to an equation or an inequality. So first, what is an equation and what is an inequality? An equation is formed when you have two expressions with an equal sign between them. And you create a left side and a right side. And in the future, when we get to chapter 3, we'll be referring to left side and right side quite a bit. You should already be familiar with this. So the key to an equation is it's two expressions with an equal sign between them. A solution of an equation is a value that makes it a true statement when it's substituted for the variable. That's what a solution is. We're looking for true statements when it's substituted. An inequality is the same idea, except instead of two expressions being connected by an equal sign, it's being connected by an inequality symbol. Greater than, less than, greater than or equal to, less than or equal to. So again, two expressions connected by an inequality symbol. The solution of an inequality, again, is a number that produces a true statement when it's substituted. But there's a major difference between solutions of an equation, a solution of an equation and a solution of an inequality. An inequality can have many solutions. Most equations that you're going to be dealing with for the first half of the year only have one solution. The second half of the year, you'll be dealing with equations that have more than one solution, but an inequality can have many, many solutions. So today we're not going to be solving equations. We're going to be given a solution, and our job is to figure out whether or not it is the valid solution. Are there any questions so far about any of the language I'm using, any of the words, phrases, anything at all? Now, I am going to move on to the next screen. If you are missing any pieces of information, it's not a big deal. Skip a couple of lines on your paper, and you can either borrow a friend's, you can borrow my printed copy later on. There's a bunch of different solutions. So don't stress about it. Just leave yourself a few lines of space. So we're going to jump in and start figuring out whether or not we have solutions to equations. So example 1. We have the equation. Example 1, part A. We have the equation 5x plus 3x equals x squared plus 7. And then we are given this piece of information right here. This is not part of the equation. That is a proposed solution. So I'm saying maybe this is a solution, maybe not. We have to figure out if it's the right one. I already gave you a clue as to how to do this. We take the value, plug it into the equation, simplify, and see if we get a true statement. So, we're going to rewrite the equation, but we're not going to have the x. So we got 5 times we're going to put in a 1, I'll put that in a second, plus 3 times, we're going to put in a 1, equals 1 squared plus 7. And just to illustrate what was done, I'm going to use a different color so you can see it. So it's 5 times the 1 plus 3 times the 1, 1 squared plus 7. Now we have to simplify everything and see if it comes out true. So, now you know why we did the lessons we've done already. Now you know why we talked about order of operations. We had to understand order of operations to be able to do this. Okay? So let's do the left-hand side first. 5 times 1 plus 3 times 1. Could someone, using mental math, tell us what the value of that is? Zabari? Which is? 8. So the left-hand side has the value of 8. And what we're saying is that equal to what we get on the right? What do we get as the value on the right? Come on.
8.
We get 8. So we get the same value. So what we have figured out is 1 is a solution. So the answer is yes. Yes, 1 is the solution to the equation. So the answer is yes. But this proves it right here. You cannot put this without proving it with something like this. Because it's a yes or no question. You could take a guess and you'd get it right half the time. So we need proof. Okay? Any questions on what we did? So we use substitution, we use mental math, and then we decided on whether or not we had a true statement. Any questions? Good. So let's up the complexity a little bit. Again, I am proposing 646 as a solution to this equation, and I would like to know, do I have the correct solution? So we've got 646 over 19 minus 34. Does that equal 15? This one's a little bit more complex. What do we have to do first based on what you learned this week? Jada?
Divide 646 by 19.
Good. Give me a thumbs up if you can do that mentally. Good. That's what I expected. Pick up your calculator and do 646 divided by 19. What do we get as a result of that? We got a whole bunch of people who know. Catalina?
34.
We get 34. So we end up with the expression 34 minus 34. Does that equal 15? And so what is your response to that? Anissa? No, they're not equal. 34 minus 34 is 0. 0 does not equal 15, so the answer is no. No, 646 is not a solution, and I just proved it right here. Are there any questions on how we did that? Questions, comments, concerns? Good, we're doing well so far. Let's see how you do on your own. Checkpoint number 1. You do not have to copy the original question, but you have to tell me the solution, and you need to be able to prove it. You got a minute and a half. Well, ultimately, it's a yes or no question, so let's do this one by survey. Give me a thumbs up if you think that 3 is a solution to that equation. Thumbs up if you think it is a solution. Nobody thinks it's a solution? Good, because it's not. The answer is no, it is not a solution. But now I need proof. So could someone tell us, after we work through all of the simplification, what do we end up with at the end? What do we end up with at the end? Brandon?
7 = 81.
Yeah, you end up with 7 is equal to 81, which of course is not true. And that leads you to saying no. Kamoy?
That little sign, the little squiggly thing above the
It's just a question mark. Sorry. Yeah, I'm just indicating that, because if I left it like this, that's a little confusing because 7 does not equal 81. So I'm saying we're asking, is 7 equal to 81? And that's all. Thank you for pointing that out. I guess I went a little too quickly. Any comments or questions, concerns? Okay, so now let's apply the same principles to inequalities. I've been using the phrase true statement repeatedly on purpose. It's especially true now with inequalities. We're looking for true statements, but the problem is there can be many of them. So I'm proposing that 3 is one of the solutions to this inequality. I started with a very simple one on purpose. So we will plug in the 3 plus 5, and I'm asking right now, is that less than 9? Is 3 plus 5 less than 9? So is that a true statement or a false statement?
True.
It is true, because we have 8 is less than 9. That's a true statement, which means 3 is a solution to this inequality. So the answer is yes, and this proves it. Any questions about that? So now that was not the level of work that you should expect. I just wanted to introduce the idea. And so here is a more reasonable question for the level of class that you're in. So it's a bit more complex, but the same principle holds true. We want to see, is 2 a valid solution to this inequality? So we've got 6 times So now we want to simplify the left, simplify the right, and see if it's a true statement. So we use the order of operations. 2 minus 1 is 1. 6 times 1 is 6. And I'm asking, is that greater than or equal to 8 times 2 is 16. 16 minus 7 is 9. So is 6 greater than or equal to 9? Dayanara, what do you think? No, it's not. So this is a false statement, and that means that 2 is not a solution. So the answer is no, and this proves it right here. Any questions on how we did that? I have another example just to illustrate, but we're not going to do it, just to look at it. Again, same idea. You plug in the number, see if the left side is less than or equal to the right, and decide if it's a true statement or not. I don't think we need another example. I think you guys get the idea. I'd rather you try one on your own. So let's go to checkpoint number 2 and see if you can determine whether or not 7 is a solution to this inequality. And again, you got a minute and a half. So let's take a survey again. Give me a thumbs up if you think that this is a solution to the inequality. Give me a thumbs up if you think it is. We got some people think it is, some people do not. We do seem to have an overwhelming majority of the class thinks it is a solution. And the answer is yes. It is a solution to the inequality. So let's illustrate why. Plug in the 7 here, and you get 7/14. It's less than, and we get 7 minus 1 over 9. Could someone put 7/14 in simplest form for us? What is that in simplest form, Alyssa? Very good. That's 1/2. And so we're saying is 1/2 less than, and now 7 minus 1 is 6. What's 6/9 in simplest form? 6/9, Brian? 2/3. And so we're saying is 1/2 smaller than 2/3, and it is. And that's what leads us to a yes. Any questions?
How do you know the difference if it's supposed to be a fraction or division?
It's both. So we would get the same answer if we did the division. So if we convert 1/2 to a decimal, what do we get? 0.5, right? You guys know all of these off the top of your head. So 0.5 is 1/2, 2/3 is 0.67, so 0.5 is less than 0.67. So either way, so you're saying, how do I know when to actually do the division? You'll know. Over time, you'll just start to know based on your experience, okay? All right, I'm going to put up the real world example that we're going to be working on. It's a little bit different. You're going to read the question, do not copy the question. Read the question, do not copy the question. All right, so of course you write example 3, but I said you did not have to copy the question, but you are going to copy down what we do together. So whatever I write, you're going to write with me. Now I'm going to start teaching you some techniques or some ways of organizing yourself so that you can be successful. But I want you to keep something in mind. I know that you guys, a lot of you could figure this out with very little effort. That's not the point. The point is to start establishing ways of organizing so that when I give you a question in one of these more complicated sections, and it's much more complex and more involved, that you can apply the technique you learned today to the more difficult question. It's the idea of riding a bike with training wheels and then you take the training wheels off, right? The training wheels are there to support you. Okay? At the beginning you need them, and then later on, when you become an expert, when you're my Jedi Master, then you can take the training wheels off. A lot of the questions we're going to be working on starting today and for the first couple of months are going to all have a lot of similarities. One thing that they tend to have in common with each other is there's usually a total somewhere in the question, or a number that represents the end. Okay? So we're going to first look for that number. We're going to look for a total, an end, something that represents, a goal. So, can anyone identify the number in this question? Sebastian?
$249.
Yeah. Hopefully just your way of reading led you to the conclusion that 249 is the total. Yes? Well, it says that the 249 already includes the tax, so we don't have to worry about tax in this case. You will have situations later on where you do have to deal with tax. Now, the second thing that they will very often have in common is called a rate. A rate is a number that you use in conjunction with another number. A rate is something that tells us the pattern. So, can anyone pick out the rate in this question? Eric? Yeah. What told you that was the rate? You already said it.
Per.
That's right. This part right here, the per week, tells you that that's the rate. We're in algebra, so the thing that we need to find is the missing piece. So the last thing we need to identify is what is missing. So could someone tell us what is missing from the question? What are we trying to find? Sharif?
The amount of weeks you have enough to save.
Good. So what should we use for that? Well, I don't want the answer. I want a letter to represent what's missing. So it's weeks. So what can we use to represent what's missing? Sure. We can use a W. We could use an N. We can use anything we want. There's one last thing we need to identify, and that's an operation. What operation is going to be used in our equation once we set it up? Alyssa?
Division.
Division? What told you it's going to be division?
It says in how many weeks will you have enough saved.
Good. So that told you it's division?
Yeah.
Okay, good. So let me come back to that. So now let's start setting up our equation. The total almost always goes all the way at the end, on the right. So let's take the total and put it down on the right. Equals, and now we need to do something with the other information. Alyssa says division, and I think I understand what she's getting at, but I don't know if she realized that we're going to set up an equation first. So if I set up the equation first, I'm not going to use division. There's something else we're going to use, and it's indicated somewhere in here. What is the operation that we're going to set up? Go ahead, Alyssa. Yeah, what tells us it's multiplication? Very good. That was brilliant. Yeah, per tells you that we're going to multiply the number of weeks times the rate. The rate almost always gets multiplied times the variable. So we end up with 8w equals 249. And she was right. We are going to use division to solve it. But setting it up, it's a multiplication equation. Okay? And so, how many weeks is it going to take? Got 1, 2, 3, 4. You already said it. What do you think? 32. Well, Alyssa, we do division to solve this. What do I divide? 249 divided by 8. I got 31.125. So where'd you get the 32 from? Go ahead.
Well, since there was leftover, you wouldn't have exactly that amount if you just had $8 for it. So you need another week so you could get more than the amount.
That was a brilliant explanation. Since it came out to 3.125, W, when you solve this, comes out to 31.125. I don't think I said that right the first time. 31.125. If you only save for 31 weeks, you won't have enough money. So you can't save for a part of a week, so she was absolutely correct. You must save for the 32 weeks to actually end up with enough money. Very good explanation and excellent work. Does anyone have any questions on what we did? Now, I mean, some of you were sitting there like, well, how do I got to do all this? I knew the answer 10 minutes ago. But remember what I said at the beginning. We're going to be getting in this habit now so that when I give you a scenario much more complex than this, you will be able to pick out these pieces of information. It's going to make your life much, much easier later on. Okay? Good. Draw a line across your paper. Your classwork is in the workbook. You're going to do page 5, numbers 20, 17, 16, 15, 14, 10, 9, 8, and 7. Some of the questions you will finish quickly. Some will require a little bit more effort. If you can do something mentally, by all means do it. But I should see some evidence of work. Someone from the back over there, if you could get your pile. Someone from the back over here, get your pile. Someone in the back over there, get your pile. You have about 10 minutes. All right, pencils down, colored pens up. Let's see how we did. Number 20. I was looking for 30x is less than or equal to 145. It doesn't matter what letter you used. And it is yes. You will be able to make all of the bracelets. Or whatever the object was, I can't remember. Number 17. The answer is 6. Number 16, the answer was 8. Number 15, the answer was 64. I know we did not talk about how to do those questions. It was mental math. You were asked to mentally solve a few equations. Number 14, the answer was 6. 14 also. The last four were to determine whether or not they were solutions. Number 10 was yes. Number 9 was yes. Number 8 was no, and number 7 was no. There were 9 questions total. Make a fraction bar out of 9 and count up the number of questions you got correct. Hopefully you got 7 out of 9 or better. And then calculate your percent. And that's your baseline of how you're doing. Yes?
I did wrong page.
That's unfortunate. Yes, Alicia.
Number 15.
Number 15, you have a question on? Okay,
I did it on page 2.
that's unfortunate. Okay, so number 15. Do I have it here? Where's my number 15? Here's number 15. This is the one that's most commonly done incorrectly. Yes, you had a
Yeah, I have problem number 9.
number 9? Okay. So number 15. When you're asked to solve something mentally, what you're being asked to do is look at this missing piece and say, what number divided by 4 is going to give me 16? So what number must go here, then divide by 4 and get a 16? The only possibility is 64. What did you put? Did you put 4?
Well, I put n divided by 4 equals 6 instead of 16.
Oh, so when you wrote the question, you mistakenly wrote the wrong number. Okay, that's an honest mistake. Okay, good. Does anyone else have a question on number 15? Okay, Marie, you had a question on number 9?
Yes.
Okay, so number 9. So you were asked to determine whether or not this was a solution. So you plugged in the 2.7,
Yes.
added 4, and then you had to see, was that greater than or equal to 20? Okay, well, I can't do that math in my head, so I'm going to use a calculator. 2.7 times 7, I get 18.9. I can already tell that this is going to be greater than that because this is almost 19, and I'm going to add 4 to it. So I can already tell that that's greater than 20. So you get 18.9 plus 4, and that is greater than or equal to 20. So where did you go wrong? Did you maybe just multiply wrong, add wrong?
No,
Or?
I forgot to add the 4.
Okay.
I just left it 18.9.
Okay, that's understandable. Are there any other comments or questions? Okay, draw one final line across your paper. One final line across your paper. You're going to do page 24. Numbers 18 through 34 even, and number 46 and 48. I cannot overemphasize this. Those are not optional questions. Those are the most important questions. That's a total of 11 questions. You are to read pages 35 to 37 and pages 43 to 45. You must read. And you will have a quiz on Wednesday that will be 1.1 to 1.3.